Okay, let's get going here. Today is 5/12. This is video number 74. And this is an important video, especially if you've never seen this stuff before, because I'm going to talk about the multiplication of polynomials, or if you like, the multiplication of expressions, algebraic expressions. We'll call them polynomials generally, but as you've seen, in many cases, the words are interchangeable. So we know that a monomial is one term. We know that a binomial is two terms. So let's take a little experiment here, and let's multiply a monomial, say 2x squared. And let's multiply it by a binomial. And let's just call this binomial x minus 2. So let's go over the fact that we got our words down correctly. Let's see what's happening. 2x squared is a monomial, second degree. We're calling it a quadratic monomial. X minus 2 is a linear binomial. X is 1 here. So how do you multiply these two? Well, you multiply them just like we were doing when we were doing algebra. Okay? There are the arrows. Of course, you don't have to draw them. And there's a 1 here, so 2 times 1 equals 2. And x squared times x to the 1 is x3. Let's pause there. You're supposed to know the product rule. When the base is the same, you add the exponents, remembering that x has a hidden 1 there that we never write out, and never in the textbooks. 2 times negative 2 is negative 4. And since there's only a 1 here, there's nothing else to multiply it to. We say that the x squared carries over. And so there you go. You've just multiplied a monomial times a binomial. And it's going to turn out for us that it's going to be more important to go from here to here. And we're going to give that the name of factoring, but not today. But going from here to here will turn out to be far more important than multiplying a monomial times a binomial. Well, let's take a look at another case here. Let's multiply the same monomial times a trinomial. So to make it a trinomial, we have to have 3 unlike terms. So we'll do something like this, just a random trinomial multiplied by a monomial. And so I'll go left to right here. 2 times 1 equals 2. We'll make sure that we're giving you space so you can see over here. So that's 2, and 2 plus 2 is 4. So you always remember the product rule that you learned in 8th grade, that when you multiply the base of a certain power, you add the exponents, okay? And you multiply the coefficients. 2 times negative 2 is negative 4, and x to the 3 times x to the 1 is x to the 3. So if you haven't seen this before, or this is strange to you, you make sure that you watch this video a second time, because I'm doing things that, I'm not going to repeat all the time. And then any number times 1 is that number itself. So we see that a monomial times a trinomial is always a trinomial. A monomial times a binomial is always a binomial. So it seems like when you multiply something by a monomial, only the degree changes, not the number of terms. So that's worth noting as well for your average freshman. Now notice again that you can go from here to here, and we're going to care more about that than, like I said, this little lecture here where we're multiplying. But soon we want to do a thing that we call factoring, where we want to go here to here and here to here. We'll get to that in the very near future. So there we go. A monomial times any polynomial is that polynomial. That is the number of terms of that polynomial. And only thing that changes is the degree. We mentioned the product rule that you're supposed to know, that if the base is the same, you add the exponents when you're multiplying. It's term by term. This is a trinomial. There are no like terms here. This is a binomial. This is called a quadratic trinomial. This is your linear binomial that you learned with slope, and the straight lines that you learned with slope. So you're starting to put some new ideas together, and we see that we easily multiply polynomials. So now I'm going to take you right away to the next step in this math that we have to do. And this is multiplying a binomial times a binomial. And a very important math. So we'll get at it right away. I should have wet this towel here, but we should get away with it this morning. Sorry about that. It should be okay. And cleaning up here just a little bit so we can do this math. Made a little mistake there, but it should be okay. And now comes the question that we're going to stop here and spend quite a bit of time, not quite a bit of time, but certainly a certain amount of time talking about something that's really a brand new idea. And this is the idea of a binomial times a binomial. Okay, so I'm going to write two linear binomials out, and right away most of you will agree with me that this is a binomial. There's x to the 1. There's another binomial. In a minute, we'll talk about the fact that you can represent these as triangles. Excuse me, I misspoke, as rectangles. But we'll get to that maybe a little later. And we have to learn a way to multiply this times this one more time. Because it's in the parentheses, the algebraic expression is a separate thing. So it's like multiplying numbers, but now you have 4 terms to worry about. So this old method, this method that's been around since the beginning of time, is called the FOIL method. So I'll teach you how to do this 2 ways, okay? We'll have another lecture that reviews this, and then we'll, like I said, we'll try to turn them into rectangles, into geometric figures so it makes more sense. But be reminded, I can put any binomial here, as long as the terms aren't like terms, and make this method work. And we're going to call this method, it's been taught, it's in all the textbooks, so I only do you a favor. I don't really use it that much. We'll use it more than any other method. Most kids use mental math when they do this. So the FOIL method is only saying that you're going first, outer, inner, whoops, that's an E, okay, and then last. So it's just telling you how to draw your arrows. We've talked about it so many times. The arrows are the indication of multiplication. So there's first, put a little F there, and the arrow. There's outer, go right there, okay. I don't know, again, I'm just teaching it because it's in all the books, and when I do mental math, I use this method as well. There's your inner terms being multiplied, and there's your outer terms being multiplied, okay? So I'll leave this here just for a second, so you can see that you multiply 4 times. You can get up to 4 terms. When you multiply 2 linear binomials, you're always usually going to get 3 terms, and that's what we'll get here. And like I said, we'll go into it more and more, and little by little. So I'll move the camera over a little bit, and then I'll multiply this for the first time. So let's see what we have. We have 2x times 3x is 6x squared. So the weaker students should see that clearly. 2 times 3 is 6. X to the 1 times x to the 1 is x to the 2. Then I go to the outer. 2 times 2 is 4. X tags along. Then I go to the inner. Minus 1 times 3x is minus 3x. I'm checking there, yeah, we're in great shape. And then minus 1 times positive 2 is minus 2. We combine the like terms in any algebraic expression, in any polynomial, 4 minus 3, since they're like terms. And the correct answer here is 6x squared plus x minus 2. And this is usually what's going to happen when you multiply two binomials together. You're going to get a trinomial quadratic to the second degree, as long as one is linear and the other is linear. Okay? Now, I'm certainly not looking to confuse anybody, but to do this properly and to give you assignments, I'm going to do it the old-fashioned way. And I'm going to imagine over here, I'm going to move the camera in a second. And this will give a lot of kids the idea of what's really going on here. Go ahead, Peter, it's okay. Okay, and I'm just going to multiply this the old-fashioned way, okay? And there's lots of ways to look at it, but here we go. 2x times 2 positive is 4x, okay? And 2x times 3x is 6x squared, okay? And now I go over here, a squared. Negative 1 times 3 is negative 3x. And finally, we're over here, negative 1 times 2 is minus 2. So there are lots of ways to do it. I could have done it this way as well. I'm just multiplying all the 4 terms, and there's my x, there's my minus 2, and there's my 6x squared. I'll have to add that as a general rule, we use the FOIL because in the heat of battle, we need to know the product of two binomials in order to know something else. So typically it's easier to do mental math using it this way, but again, I could have multiplied this different ways. After all, 1 times negative 2 is negative 2, 2 times 2x is 4x, and now I go to the other side, 3 times negative 1 is 3x. So you could do it any way you want to line these guys up. Either way, you get the same answer. I've seen charts where this is done, but we really shouldn't knock ourselves out that much with this, just remembering the basic ideas. Now, I'm going to get that out to you as soon as possible because the next assignments will reflect work doing this, okay? All right, let's stop here. Oops.